Hello friends, today we are going to discuss about the calculation of the interactive force. Interactive force. Interactive force called double summation R pi R, which was the part of the virial equation that we have discussed earlier. This interactive force is basically the molecular force, which may also be called as intermolecular force. So what is the outcome after the deduction of this particular double summation R phi R? The deduction would lead to the developing a equation of state for non-ideal gas. Equation of state for non-ideal gas. To start with, we have been faced with two important considerations. Number one consideration is that the molecule should be considered in pairs. Molecule should be considered pairs. So if n is the number of molecules in the system considered, then NC2 pairs of molecules are present. That is, this is just simply n into n minus 1 by 2. As n minus 1 is, as n is very greater, so n minus 1 is equals to n. So we can write this factor as n square 2. This is the first consideration that we make. The second consideration is there. We have got to find the molecules in the range R and R plus dr for the first molecule under consideration. Let the first molecule be considered as A. Say A is the first molecule, and suppose we are going to find the number of molecules between R and R plus dr. We are finding the possibility of the number of molecules within R and R plus dr for the molecule M, for the molecule A. So this can be easily found out by taking out the volume of this dotted area, that is 4 pi R square dr by V. V is the volume of the system. So this is the expression. Now, if the distance between the molecule A and B is R, suppose, and if this is the case 1, this is the first case, and we consider another case where A and B are two molecules and they are spaced with R very large distance, then it is being found obviously we will have number of molecules in this particular case greater as compared to this. So you have R very large number of molecules in R very large system as compared to R normal distance R, that is equals to e to the power minus 2h chi, where chi is equals to 0 to R phi R dr. So this is the expression. So this is the expression. So now condition 1 and 2, if multiplied, they will give you the number of molecules that are there at an infinite distance, number 1, are considered in pairs and within the range of R and R plus dr. This all conditions has to be met to find the number of molecules within the range of R and R plus dr. This range has become infinite, very large distance. This distance has become very large distance, and the number of molecules under consideration is n, and we have found the pairs, number of pairs is n square by 2. This is the pairs that we will be getting, and we are considering another important factor that is called chi, which is equals to 0 to infinity phi r, where phi r is the functional force that is dependent upon that is dependent and is related to the interactive forces between the molecules. So we write down here, by multiplying all these three conditions, we get 4 pi r square dr by v multiplied by n square by 2 multiplied by e to the power minus 2h chi. So this is the fact that we have. So we can cancel this and find 2 pi by v, and here you have n square, and the integration for the range of for r equals to 0 to infinity, for very large distance between the molecules, we have 0 to infinity r square dr e to the power minus 2h chi. This is what we have. So our expression for intermolecular force is 1/3 double summation R phi r. So what do you have for that? Then we already have the number of the molecules in this taking participation in this interactive forces. So just have to multiply both sides by R phi dr and 1/3. So the total force, this is the expression of force. So here number has been calculated. So we just simply multiply and remove the summation. So we have this 1/3 got here, and in place of summation you have to write this part 2 pi n square by v integration 0 to infinity r square dr e to the power minus 2h chi. This has been replaced, the summation has been replaced by the number of molecules representing the intermolecular forces, and obviously r phi r. And here phi r is considered as minus d chi dr. So this is our whole expression. So rewriting the Virial equation, 1/3 summation mc square plus 1/3. Let's assume this part as capital Z, 1/3 into Z R, phi means d phi dr. We dropped out this negative sign. Considering this force to be repulsive by nature. So we just write it down over here. We replace this term by PV is equals to nRT plus 1/3 to pi n square by V 0 to infinity R cube dr e to the power minus 2h chi d phi dr. It's okay? Okay. Now we got to replace this whole stuff like with B equals to 2/3 pi in pi RT by RT integration 0 to infinity R cube dr e to the power minus 2hx into d phi dr. This is the value of B, what you have got, capital B. So if B is this, so we can rewrite this equation as PV is equals to nRT 1 plus dy V. Now if we consider this R, the value, this is for, we have this B at R equals to R was the original. Now B, when R is equals to sigma, that means diameter of the molecule. This equation reduces to 2/3 pi n sigma 3, and this is considered as small b, another constant. As of now, we were dealing with the repulsive virial. Now there's another virial which is responsible for the cohesive forces between the molecules, and this cohesive force actually is responsible for the pressure correction. What we have done over here, this will be responsible for the volume correction, and we will require the cohesive forces, the action of the cohesive forces to be acting on the pressure to deduce the pressure correction. Now it has been found the pressure is the cohesive force CF, that is cohesive force, is proportional to the density square of the gas, the volume of the gas, and obviously CF can be taken as K rho square V, where K is a constant. So, using this expression in this part, the cohesive force PV is equals to nRT1 plus. Now for, we can say V R equals to sigma V and we have some other force K rho square by V. So we shift over this side and we take P plus K M by M square by V square V into 1 minus B by V, transferring this onto this side, is equals to N. So solving this, we will get P plus A by V square V minus B is equals to N. So we have arrived to the equation for a perfect gas, and where A and B are constants, and this particular equation of the state is called Van der Waals equation of state. So that's all for now. Thank you.